Hi guys, and welcome back to another chemistry video lesson. Today we're kind of going back a few days and we're going to connect back to the first couple days that we talked about measurements, significant figures, and calculation. And now we're going to tie in a little dimensional analysis now that we're a little bit more comfortable with units. And going forward, we're going to be talking more about the measurements of matter as we make observations and as we use more descriptive language and we start doing calculations about matter. So in order to do that, we need to be comfortable with dimensional analysis. Dimensional analysis refers to when we do math with numbers that have units, and we can't do math uh, with numbers whose units don't agree. You can't talk about something that is measured in feet and something that is measured in miles, or something that's measured in meters and in millimeters. We have to make those units agree so we can talk about things within the same context. So I'm going to jump right past the IA. That's a little exercise that you can do. And I'm going to get right into the notes. So an equivalent statement is something that relates to amounts, to quantities. And that's what I've been talking about when I just said we have to make our units agree, is that we have to use an equivalent statement to understand how they're related. So equivalent statements and conversion factors are very similar. Example of our equivalent statement, 2.54 centimeters equals 1 inch. That's the same thing as a ratio of 2.54 centimeters over 1 inch, or 1 inch over 2.5 centimeters. If we have two things on either side of an equal sign and we want to move one of those to the other side of the equal sign, we will end up with one of these ratios. 2.54 centimeters over 1 inch equals 1, or 1 inch over 2.45 centimeters equals 1. So it's important to remember that these conversion factors and equivalent statements are equal to 1. So when we multiply or divide by a conversion factor, we're multiplying or dividing by 1, so we're not changing the value of the measurements that we have. When we do a dimensional analysis, we're going to convert from a known unit to our unknown unit. We have something measured and we want to change that unit to something that we don't know, get it in a new context. So we're going to determine what we do know, we're going to determine what we don't know, and then we are going to use our equivalent steps, equivalent statements, and conversion factors to get from point A to point B. So I'm going to go into presenter mode real quick. I'm use my animations here. Oh, that's not what I expected to see. All right, so I'm going to edit this part out. Okay, there we go. So, dimensional analysis, just went over these. Great. Okay, next. To convert, we use our equivalent statements, treat the units as variables, and then arrange the measurements so that they will cancel out. So this is not as obvious as it sounds, and actually it doesn't sound obvious at all. But when we arrange measurements that they cancel out, remember when I just said 2.54 centimeters divided by 1 inch equals 1? Those are equal statements. So if we divide anything by itself, it's equal to 1. That means canceling out. So here's an example. We have a new baby that weighs 7.8 pounds, and we want to know what that baby's mass is in kilograms. So first things first on the notes, we underline what we know. We know that we have 7.8 pounds. That's the unit that we know, and kilograms is our unknown unit. We want to get to kilograms. So let's write down our first equivalent statement. 1 kilogram equals 2.205 pounds. Now I'm giving you this equation, this equivalent statement. You won't always be given equivalent statements, but you can usually, if you're not given one, figure out what the equivalence is using your reference tables, using the conversion charts on your front page of your reference tables to find the order of magnitude of your prefixes and your units. So we set up our known unit, and we're going to multiply this by the conversion factor. 1 kilogram per 2.205 pounds. And when we put that in our calculator, we're going to get 3.5 kilograms. So you might be saying, okay, what happened to the pounds unit? It was in the question, but it's not in our answer. That's because the unit pounds cancels out. If we have pound in the numerator of 7.8, and we have pound in the denominator of our conversion factor, pounds divided by pounds is equal to 1. We can cancel that out and get it out of our problem. The unit that we're left with is kilograms. So you might say, okay, but if I put 7.8 in my calculator and divide it by 2.205, I get a long decimal. Yeah, you do get a long decimal, but call back to the beginning unit. The final answer that we have is rounded to 2 significant figures because that is the least amount of sig figs in the calculation. So let's look at another example. How many seconds are there in 2 days? So in our first example, we had one equivalence statement and one conversion factor because we're going directly from pounds to kilograms. But in this second example, we're going to have more equivalent statements because we're going farther from our first unit to our second. So first of all, how many seconds are there in days? Our known unit is our day, so we can circle 2 days. And what we don't know is seconds. We can underline seconds. And then we can think to ourselves, okay, where's my conversion factors? First of all, 1 day is 24 hours, 1 hour is 60 minutes, and 1 minute is 60 seconds. So we're going to have to do 3 conversion steps in order to get from days to seconds. So just like before, we set up first what we already know. Then we turn hours into days. Then we turn hours into minutes. And then we turn minutes into seconds. So before I show you the final answer, let's check our units here. We start with days in the numerator, and then we're going to multiply it by hours over days. So right there, days are going to cancel out. Then we're going to multiply it by minutes per hour. Now we have hours in the numerator and hours in the denominator. Those are going to cancel out. Then we're going to multiply by seconds over minutes. Minutes in the numerator and minutes in the denominator are going to cancel out. The only unit here that doesn't have a numerator and denominator term is seconds. So seconds is the unit we're left with. And just like before, we got 172,800 seconds, but we round that to 200,000 seconds because the final answer is rounded to 1 significant figure because that is the least amount of sig figs in the calculation. We were given our initial measurement of 2 days as 1 sig fig, so we had to round our final answer to 200,000 seconds. Okay, guys, I hope that that helped, and I hope that you can work on those 4 practice problems by yourself. If you have any trouble with those, we have virtual enrichment classes coming up, and you can also, of course, always come to my office hours. Let me know if you have any trouble, and look forward to seeing you this week.